Today we're going to look at the Chapter 2 practice test. It is uploaded in Moodle under the week of February 23rd. It does have a key, but the key only lists the solution. It doesn't show how you get to the solution. So that's what we're going to do right now. Number 1 says find the domain of the following function. I have f of x is equal to a 2 over a 2x plus 6. We know that there's going to be restrictions on the domain anytime I have my denominator become a 0, or if I try to take the square root or any really even root of a negative number. So my 2x plus 6, that cannot be equal to a 0. Any number that I plug in for x that makes this side of the expression become 0 has to be excluded. So all I need to do is solve this equation. Subtract 6 from both sides. Divide by 2, and you get x cannot be a negative 3. So everything else, any other number is fine, but negative 3 needs to be excluded. So you have a couple of different ways that you can write that. You can say, I can have all real numbers except x cannot be equal to a negative 3. You can list it as it does in the answer key using set notation, which is negative infinity to the negative 3, or from negative 3 to the positive infinity. And you could also use set builder notation that says the set of all x's such that x cannot be equal to a negative 3. And we'll say x is also an element of real numbers. Any one of these would be fine. This is the one that is listed in the answer key. Number 2, sketch this piecewise function. Now your calculator will graph this, but it only tells you half the story. If you go into your calculator into y equals, I can type in my x and then I can put a restriction on the end like we did in the Motorola project. So if I wanted to find this less than or equal to or the greater than, that is in second math. And then you would pull those guys out from in there. When you graph it, you have something that looks like this. However, if x is less than or equal to 0, you're going to use the one where y equals x. And if it's greater than, you're going to use the x minus 3. Notice that one has the or equal to and one does not, and that you can't see either dot in here. On top of that, when you go into your table, it does not cut the values off. It does not stop plugging in values, right? So you see 0, 0 here, but you can see for these negatives that you still have it over on the other side. So you're going to need to know what kind of dots to put where. If I am looking at numbers less than 0, that would be this part of the line. When you hit 0, it's going to be included on that piece of the line. Because if I plug in a 0, I'll get out a 0. If I plug in a number that's bigger than 0, then I would use the second part of the piecewise function, which starts here and then heads up. But this dot that starts off on the negative 3 needs to be open. And so this is what your graph needs to look like when you sketch it. The dots are important. If you do not put the correct dots in the right spot, then you don't really have the correct graph. So if you don't put the dots, you just draw the lines, you're only going to receive half credit. So pay attention to which is included and which is not included on which part of the line. Determine whether the equation 4x plus 7y equals 28 defines y as a function of x, and how do you know? There's a few different ways that you can do this. The easiest way is most likely to set this guy equal to y equal to an expression, so that way we can go ahead and plug it into the calculator. So I'm going to bring the 4x to the other side, and then I'm going to divide everybody by 7. So that I get y equals a negative 4/7 x plus 4. In my calculator, I'm going to put the -4/7 in a set of parentheses, x, and then say +4. When I hit graph, I'll get the line. How do you know if something is a function? If you're looking at a graph, you see if it passes the vertical line test. And sure enough, if I was going to hold my pencil up and drag it through, my pencil would only intersect the line once every time it touches the line. It won't hit twice. So this guy is a yes. It is a function because it passes the vertical line test. The x's never repeat. So you can see from the function that if you plug in a -2, you're only going to get at this number up here. You'll never sometimes go up to the number above the y-axis and sometimes below. Number 4, where is my graph decreasing? Well, I am decreasing from here to here. So from the -8 to the +4, I'm decreasing. You do not include the -8 or the +4 because that's where it changes direction. And so that's the only part where I'm decreasing. These two spots are increasing. Find the maximum value of f given the function. And so we're looking for where do we hit a peak? We hit a peak at 0. The value is a 1. So the local maximum value of f happens at x equals 0. The maximum value is a 1. And so maximums, you're just looking for where it peaks out locally. What is the average rate of change between these two values? I have a point at 0, 0 and a point at 2, 8 I'm going to estimate it at. And so rate of change is the change in my y values over the change in my x values. We usually use an m for slope. I'm going to make this one x1, y1, and this one x2, y2. And so I have 8 minus 0 over a 2 minus 0, known as 8 over 2, right? And my average rate of change is a 4. Sometimes it's a fraction, sometimes it reduces to just a whole number. Either way is fine. Number 7, find the average rate of change for the function between x equals 0 and x equals 10. And so this time they didn't give us y values, so first we're going to have to plug these values in. When f is a 0, this will be a nice one. 0 cubed is 0, 0 squared is 0. When you multiply it by a 5, it stays 0. So when you plug a 0 in, you get out a 0. And so I have the point 0, 0. When I plug in a 10, I'm going to get a little bit of a bigger number. 10 cubed minus 5 times 10 squared. 10 cubed is 1,000. 10 squared is 100. Times a 5 is 500. So 1,000 minus 500 is 500. The other point on the line is 10, 500. And then we'll repeat the process that we used in number 6. The change in my y values over the change in my x values. I'm going to make the 0, 0, x1, y1, and 10, 500, x2, y2. And so my slope is the change in my y's, 500 minus 0, over the change in my x's, 10 minus 0. Doesn't always have to be zeros, of course. So 500 over 10, 50. Number 8 says find the slope of the line using the graph. And so you go up or down first and you read it from left or right. So I start at the 2. I'm going to have to go down 1, 2, 3. And then I'm going to have to run 1, 2, 3, 4, 5. So I need to use this point over here, this 5, -1, because notice over here for that 3, 0, it doesn't go through exactly. So that means you can't use that point just because it's close. you have to go all the way to the one that it intersects perfectly at like the edges of the boxes. And so my slope for number 8, I'll put it in right here, is a -3, run 5. And that's my slope. Number 9, I have a tank that's being drained at 17 gallons a minute. Tank started out with 17,750 gallons of water. Write a linear function to model the number of gallons of water in the tank at time t. So I started out with 17,750, and every minute that I'm going to measure in t passes, I lose, so minus 17 gallons. And so I can say f of t is 17,750 minus 17t. If you like it written where your variable is listed first, you can say negative 17t plus 17,750. Number 10, which of the following functions are linear? A linear function is a function that has x to the first power, and that's the highest. And so you can see here we have an x squared, not linear. Here we have no x, not linear. Here I have x to the first power, he's okay. And I have x to the first power here, so he's okay. This is actually x to the -1, and so that one is not okay. So b and e are our linear functions. Now the answer key lists b and e, but it also includes d. And if you remember us talking about a little bit in class, technically this does not have x to the first power, and so he would not be considered a linear function or a linear equation, but a lot of times because my y equals a -5, and we'll also say for like if it was just x equals a -5, those do draw lines, and so sometimes we kind of just let them be a member of the club. So if you list D, I would accept that, but by definition, B and E are linear functions.